Hello mathematicians, thank you for joining me today as we look at the theorem that if A, B, and C are matrices of the same size, then the associativity for matrix addition holds. That is, A plus B plus C is the same as A plus B plus C. In order to prove this theorem, what we need to do is we need to think about what each of these things mean. So let's suppose I have the matrix A, then I could denote A as, we'll denote its entries as A sub ij, and let's say the size of A is an n by m matrix. So what we get is that we have an A sub ij for each I between 1 and n, and each j between 1 and m. And so my arbitrary entries are going to look like A sub ij's, and those are going to be true for everything that falls within the size. Therefore, if I look at B, I'm going to denote that as B sub ij for, and again, 1 is less than or equal to I is less than or equal to n, and 1 is less than or equal to j is less than or equal to m, so that I know that these are going to be arbitrary entries, and I'm going to have one for each of the I and j's between i's between 1 and n, and j's between 1 and m. And I can denote C in the same way. This is going to be C sub ij. So now if I take, let's say, A plus B, what I'm going to end up with is I'm going to take A sub ij plus B sub ij. And so what's going to happen is that if I want to find the sum of two matrices, I just add these component-wise. So if I want to find the entry in the ith row of jth column of my new matrix, well, I would just take the entry in the ith row of jth column of the first plus the entry in the ith row of jth column of the second. So I'm going to end up with A sub ij plus B sub ij. Now, the important thing to note here about the size is that because they are the same size, I'm going to have an A sub ij for the i's between 1 and n and the j's between 1 and m, and I'm going to have a B sub ij for exactly the same i's and j's. So therefore, if A sub ij exists, B sub ij exists, and conversely, so my addition will be defined because I won't have any points where I'm trying to add this to a non-existent number. So for each of these points, I will get that A plus B is defined, and it is A sub ij plus B sub ij. Alright, now that I know what A plus B looks like, I'm going to determine what does A plus B plus C look like. And so we said A plus B was equal to A sub ij plus B sub ij. And then at the end we're going to add our C, which is our C sub ij's. And so we got here, this was just A sub ij plus B sub ij. And now with that we're going to add our C, which is our C sub ij. So if we follow the process we just did, is we're going to add this matrix plus this matrix. That means we're going to add component-wise. We note that C is the same size as A plus B because it's the same size as A and the same size as B. So what we end up with is, well, this addition will be defined, and it's going to be a matrix that looks like the terms from the first matrix, A sub ij plus B sub ij, plus the terms from the second matrix, which are the C sub ij's. And so we have a matrix whose arbitrary entries look like A sub ij plus B sub ij plus C sub ij. Now, since these entries are going to be in some field, likely the real numbers, but in general any field is associative under addition, what we're going to get is, well, because this addition is associative, we're going to end up with, well, A sub ij plus B sub ij plus C sub ij is something like 4 plus 3 plus 2 would be, well, if I change the parentheses, I don't change anything. So I get A sub ij plus B sub ij plus C sub ij. And so now the insides are exactly the same because addition is associative over that field. So I get that these two are actually exactly the same. If I take that a step further, what I can do is kind of work backwards from what I had here is, well, when I had the parentheses here, I could break it up into two matrices. So I can break this up into A sub ij plus B sub ij plus C sub ij. And now the last thing I notice is that this is just A plus And now this is just B plus C. And so what I've shown is that if I have A plus B plus C for matrices, then that's equal to this, and in the end it's equal to this. So what we get is that this is equal to A plus B plus C. So that is, if I change my parentheses, instead of being around A plus B, they're now around B plus C, we're going to get the same thing. So associativity of addition for matrices does hold. Thank you for watching. As always, I hope you learned something today, and I hope you enjoyed the process along the way. If you did, make sure to like the video and subscribe to the channel. It helps me to know which videos are helpful, and it helps other people to find these videos so that they can also get help. Thank you.